All right, this is our last video for chapter 4. So congrats, you've almost made it through. And in this one, I want to talk to you about sources of energy, energy consumption, and things that you can maybe relate it more in your everyday life. So on this picture, you may not necessarily want to relate to those chapter numbers because this is from another version of our textbook. If you want to learn more, you can visit the link. I'll be posting that also in Canvas. So if we were in class, I would ask you to come up with different sources of energies and see, and you've already done that when we've talked about sustainability and coming up with a theme for your final projects. And I think that's why this is of interest to a lot of you, because you've mentioned, wanting to learn more about nuclear energy. So these are things that we're going to talk about in later chapters. But just to give you an overview of the different ways you can actually get that energy we've been talking about throughout the chapter. So you can see that at the center of everything here we have the sun. And the energy that we're getting from the sun is actually from nuclear reactions. And again, we'll talk about that towards the end of the semester. But that produces that energy in the sun, and ultimately that's how we're getting a lot of our energy here. One obvious way to to actually get that energy directly is by using solar panels, for example. But you can also use the heat itself, and there's different ways that you can use up that energy that's coming from the sun. And then so you can see here we talk about radiant energy. Again, something that we're going to be talking also more about when we talk about radiation, but also optics. And so things that are going to come up in later chapters. So this somehow also connects to those windmills that you see here, and you may wonder why, but this actually connects to this thermal energy. And again, that's something that we will also study this semester as we talk about thermal physics, thermodynamics. If you think about where the winds come from, it's actually from the movement of air in the atmosphere, and that is all consequences from fluid dynamics, and also this thermal energy that's setting all of this in motion. And again, things we'll talk more about as we talk about fluids and also thermal energy. And you can see that then you can take the wind energy, convert that to mechanical, so that mechanical energy, and convert that into electricity. And over here you have chemical energy, and here we look at something that is burning, and this is once again something that we're going to be talking a little bit more, but really you can see that this is actually more something that you would study in chemistry. So all of these reactions, if you've taken a chemistry class, all of these kind of also connect back to electrical energy. And so we can either take, radiant energy and convert that to electrical. We can take that mechanical energy from those windmills and connect that to electrical energy. There's ways, we'll see once again, that's going to be in a later chapter, that you can create that energy also by other means. But it's a little bit early to talk about that because we haven't talked about electric force and all of that good stuff. But again, later on in the semester, we will be studying electricity. We're going to be looking at electric charges And as part of that, we will talk about energy again. So we'll see this concept come up on, almost every chapter. It's going to be something very important, and you can see that there's many ways we're going to be able to apply this. Now, if we think about, so these are different sources, and we can see it here, a diagram that shows you how much energy is actually used, but also how. And so this is actually something that is important even in terms of social justice, because the way that the resources are distributed is going to impact some populations more than others, and also in terms of pollutants, and the cost of energy is something that needs to be accounted for. And it's extremely important for the economy. And some economies are highly reliant on various sources, and so it's something to take into account. And also looking at how we use that energy, and the way that we approach, not only we've talked about efficiency, and how well we should be using that energy, but it's also how much, and what kind of sources of energy we're using. So you can see that on the lower diagram here, we can see the total world energy consumption by source. And unfortunately, you can see that the majority of this is coming from fossil fuels. That is not great. So over 80%. And we're trying to get this down, because these tend to produce, it tends to aggravate the issues that we've been dealing with in terms of climate, because there's going to be so first of all, they're limited. So eventually, if we just use that, we're going to be running out. It takes a really long time to get that back again. So to produce them takes the life cycle of this is extremely long. But not only that, in terms of CO2 emissions and things like that, it tends to be a lot worse than renewables, for example. So we have renewables, and we're trying to get this number to go up higher. And then there's nuclear also. So nuclear is fairly efficient, but as you may know, there's also important issues that may be associated with that. And again, that's something that we'll talk a lot more about, how does that work, and how can we, what are the processes that are going into creating nuclear energy. And so it's very appealing, and also just thinking about consequences, as you may have heard in news in Fukushima, and if you've seen Chernobyl, also definitely things that we need to keep in mind. Now, if we focus on the renewable part, so this is a little green piece of the pie that we have here. So you can see that there is a lot of various things that we can use. And I will let you read through the list, probably some that you thought about. So, we've talked about wind power. So here, solar, hot water would be if you keep, you can have pipes that are filled with water, and, they're essentially absorbing the heat from the sun, and you can heat it up that way. Hydropower, if you look at, a dam, or there's different ways to do this. Geothermal is also a very interesting one. I think that is picking up more, but you can see that a lot of them, they're giving out a very small percentage. So this is all adding up to the 16.7% that we have here. So you can see that these numbers are global. So it's interesting to see, how can we maybe shift these so they grow up to catch up with fossil fuels. So just also going back to, when we talk about renewable sources, what exactly are we saying versus the non-renewable sources? Here, renewables means that the source is going to replenish through naturally processes. And the time scale for that is a lot shorter than, when we'll have non-renewables, meaning that, so if, for example, if you take solar energy, it's available most of the time, depending on where you are. But even if, depending on your location, once again, you can have access, most of the time, except, at night and whatnot. But you don't have to wait centuries to get, you can just use it and then it's still going to be there, right? So same with wind. So there may be times where there's less, but it's going to renew itself naturally. Versus when we're looking at non-renewable sources, so these ones is, you're essentially extracting them, and the processes that go into creating them, if you're looking at oil, and even other natural gases and things like that, they you can convert them fairly efficiently. However, as you do so, that we're producing things like CO2 that are not helping our problems right now. But also, once you use it, it's gone, and it takes a really long time to produce those. And again, you have some natural processes to do so, but they take a really, really long time. So it's not like we use it and we'll get it back tomorrow. Basically, we use it and it's gone. So but yeah, so things are to keep in mind, because even if there were no drawbacks to using oil, eventually we will run out. That's another issue that comes with this. And so if we think about applications also that are relevant, I think, for a lot of you, when we think about the human body or just life in general, it's important to think about those concepts as things that apply to you, to your own body. And every cell in your body is a machine, like we talked about when we talked about efficiency. And so they need an energy supply. All right, so we talked about calorie intake and whatnot, but now we're looking at what's actually going on in your body, or any living cell, really. And so you may have heard the mention of metabolic rate, and that essentially is the rate at which your body is going to use that energy, so that food intake, that calorie intake, to sustain the life, and to make sure that the cells are able to do their work. But also to make sure that you're able to walk around and do all these things that you need to do. And so the way it works is that in your metabolism, your intake, so a lot of glucose, or like things that that is essentially what's coming in, which is essentially carbon, it's going to combine with the oxygen that you're also taking in, and that's going to transform into carbon dioxide that you're releasing, but it will also release energy that you can use. Okay, so And that's a lot of, so you know, that's a very common process, and something that you're doing all the time, so without even realizing it. And there's different ways that these reactions can happen, and then at that point we're touching more, we're getting into the realm of chemistry. And so it's if you were just to set, so if you took a little bit of sugar, you know, and you ate it, and then, you know, your body is going to transform that into, so you combine that with some oxygen, you're going to produce that carbon dioxide and release that energy in your body. All right. That is going to be a lot slower than if you just set your sugar on fire and make caramel. It's, you know, a similar idea, um, but the good part is that the energy is going to be released as you need it, and that, you know, it's a very well performing machine. And you know, again, I know that a lot of you are interested in going into you know, some healthcare fields maybe, and if you want to learn more about how those relate, again, I'm going to put this also in Canvas, so you can read more about that if you wish. All right, so I just wanted to wrap this chapter on ways that you can connect those concepts maybe to things that you do every day, the way that you consume energy, just, you know, by using your computer, or, you know, as you're maybe cooking food or something like that, but also in terms of how you use your energy in your body. And so even though it may not necessarily seem this way, because it seems like, you know, this is biology, or it does use physics principles, and the ideas are the same. The energy that we talk about is the same, and so you can keep that in mind as you know, when you're talking about the work that we've defined it, and conservation of energies that are extremely important concepts. I would try to think about how you can apply them to your everyday life. All right, so thank you for listening, and I'll see you over for the next chapter. All right, thank you. Bye.